Hello, everyone, and welcome to the Sky this month for February 2023. My name's Paul Martinaitis, and this show is brought to you by the Astronomical Society of South Australia. So I hope wherever you are, you've had some good weather over the last month or so to let you get out and observe our wonderful skies. Here in Adelaide, it's been pretty good, and a lot of us have been able to get out and do some nice observations. So in this month of February, there's not so much going on with the planets, but there's still plenty to look at, of course. So we'll begin as usual by doing a tour of the sky. We'll then look at the lunar calendar to see when are the best times to do deep sky observation. We'll do a tour and see what's going on with the solar system, and then we'll talk about a few of the nice objects in this month's constellation of the month, which is Canis Major. So without further ado, let's begin with a tour of the sky for February 2023. So we'll begin our sky tour as usual in the west. So this shows you the situation on the 15th of February, and the time is 10 p.m. So somewhat about half an hour, 45 minutes after astronomical twilight. So the main constellation of interest in this part of the sky is, of course, Eridanus, the river, second longest constellation after Hydra, and it makes its way all the way from Orion in the northern part of the sky, winds its way all the way across and finishes in the south in the relatively bright star Achernar. So quite a few galaxies. So if I zoom in, you can see all the galaxies starting to appear around Eridanus. And also, of course, probably the best planetary constellation, planetary nebula in Eridanus, which is NGC 1535. So we've talked about that before. NGC 1535, always worth a look, even under a suburban sky, because it has relatively high surface brightness. So that also means you can use plenty of magnification on it as well. And like almost all planetary nebula, it will also respond very strongly to a nebula filter, an ultra-high contrast, or better still, an oxygen-free filter. So I'll just zoom out a little bit. And also, of course, while you're looking at Eridanus, there's also quite a few nice galaxies, including the Fornax cluster as well, if you've got access to a dark sky. Okay, so now moving towards the north. So we've got Taurus. Taurus is now starting to get a little bit low in the sky, but it still makes a fine sight, particularly because Mars is hanging around in Taurus, and it makes a nice contrast with the red star Aldebaran. So you'll see two red objects in the sky. The fainter one, which is above, will be Aldebaran, the red giant star, and then beneath it will be a much brighter Mars beneath it. So Mars is really the only planet that's readily observable at the moment, except for Mercury and Venus. So you might want to get your last look at Mars. At the moment, it's about 10 seconds of arc in diameter. So if you have your telescope out, certainly still worth a look. If you've got good seeing, it'll still be possible to see some surface details on it. But as the month and the year rolls on, of course, it's going to get smaller and smaller. So I think at 10 arc seconds, this is probably your last chance to reasonably be able to see some surface detail on it until the next opposition, which will be in 2 years' time, because oppositions with Mars occur, unlike most of the other outer planets, only occur every 2 years. So while you're in the Taurus region, good opportunity to get your binoculars out. Don't forget to take a look at the Pleiades, or the Seven Sisters. You can usually see about 6 or 7 of the stars, depending on how good your eyesight is and how dark the sky is. But also a very nice view through binoculars as well. And also, if you point your binoculars up to the tip of Taurus, so there you've got Aldebaran, there you've got the tip. If you sort of look in that region, this general association of stars is called the Hades, and it makes kind of a triangular-like pattern with a lot of nice little apparent widely spaced doubles in it as well. So looking a little bit further up in the sky, of course, we can see Orion. So last month I went through some of the key objects in Orion. So if you missed that, you might want to take a look at the last show and just fast forward to the constellation of the month. And nearby to that, very high in the sky, is Canis Major, and that's going to be the constellation that we're going to focus on this month. And we'll talk about a few of the nice objects that you can view in Canis Major a little bit later on in the show. So now turning towards the eastern part of the sky, higher up right next to Canis Major are the constellations of Argo Navis. So you've got Puppis, there's Carina, Vela, and Pyxis. So they're now very well placed for observing some of the fine objects in there. And Joe Greta and I did a show, I think, called Jason and the Argonauts, which you'll be able to find on the ASSA YouTube channel. And we, both of us, went through just some of the many fine objects that you can see in this part of the sky. Well worth looking at. Main one that you probably want to have a look at, which I think most of you would be familiar with, is of course the Eta Carini Nebula. And even under a suburban sky, you can usually just see it with your naked eye. But if you point binoculars towards it, you won't have any trouble picking up the nebulosity. And looks even better through a telescope, and also responds extremely strongly to any sort of nebula filter as well. So finally finishing up in the southern part of the sky, the constellations particularly well placed for observation in this part of the sky are constellations like Pictor, Dorado, and Reticulum. A lot of fine galaxies in this region of the sky. And of course also here you have the Large Magellanic Cloud. So that's now pretty much at its highest point at this time of year and this time. So excellent opportunity to take a look at that as well. So looking at the calendar, nights are starting to get just a touch longer, and we can begin to start to observe a little bit earlier. So on the 1st of February, astronomical twilight began at 21:56 and went right through to around 5 a.m. in the morning. By the 28th of February, astronomical twilight begins at about 9:30 and goes through to 5:30 a.m. in the morning. So the dark sky period begins on around the 13th, around the mid of the month, around the 13th, and it goes right through to the 25th. And the moon phases are full moon is on the 6th of February, last quarter on the 14th, new moon on the 20th, and first quarter will be on the 27th. So looking at the solar system, you can see we're in kind of a different, the opposite situation to what we were late last year. You may recall late last year, on some months, we were able to virtually view all of the planets at some stage in one evening. Now we're kind of the opposite. There's really only 3 planets that are readily visible, that being Mercury, Venus, and Mars. So looking at the inner planets now, just those inner planets, Mercury and Venus. At the beginning of February, sort of the beginning part, Mercury is very much a morning object, so visible just before dawn as the sun is rising. Venus is an evening object, so that will be visible in the evening sky as the sun, just after the sun sets. And then as the month progresses, Mercury will be moving, getting closer to the sun from our point of view, becoming harder to observe, whereas Venus will be moving away from the sun and becoming easier to observe. And it will reach greatest elongation sometime early March. So on the 19th of February, there will be a nice alignment between the moon and Mercury. And then a little bit later on in the month, I think it'll be on about the 22nd or so. There's the moon there. The moon will make a nice slender crescent that should make a nice naked eye sight together with Venus and Jupiter. But because Venus and Jupiter at that time, it'll be just after the sun, or as the sun is setting and just after sunset, they'll be very low in the sky. So I don't think it's worth getting your telescope out, but maybe just a nice naked eye view. And maybe if you have your binoculars out, you might want to take a look as well. So moving to the outer solar system, as we saw before, Mars is really the only planet, outer planet that's worth looking at. Still reasonably well placed. Probably your last opportunity to get a view of some of the surface features with your telescope if the seeing is good. Just bear in mind that the diameter is now around 10 seconds of arc, so considerably smaller than it was at opposition. And you can see, of course, as the year goes on, the distance between us and Mars will just increase, and it will just get smaller and smaller. So that'll be our last chance for this apparition, I think, this month. And then we'll need to wait until 2025 for the next opposition with Mars. So Jupiter will soon be lost in the evening twilight. Saturn is moving into conjunction, therefore unobservable. Pretty much the same with Neptune, unobservable at this time. And Uranus is still visible in the early evening, but again, that's soon going to be lost into the twilight as well. So we'll just have a look at a quick look at those two planetary alignments we just talked about. So on the 19th, early in the morning, around 6 a.m., just before sunrise, Mercury will be joined by the moon. So that should make quite a nice sight with the naked eye. The moon will be just a very, very slender, it's just after new moon, so a very, very slender crescent. Mercury will also have not a completely full phase. So if you take a very careful look through your binoculars or perhaps a telescope, depending on the seeing, you may be able to make out that phase in Mercury as well. And finally, on the 22nd at around 8:30, so it'll be just after sunset, Jupiter and Venus will be fairly close together, and they will also be joined by the crescent moon as well. In fact, the moon and Venus should be in the same field of view as a pair of binoculars. So that might be worth a look as well. So the constellation we're going to concentrate on this month is Canis Major, or the Large Dog, and that's in fact right next to Orion, which was the constellation that we focused on in the January show. So Canis Major, very easy to find, of course, has a very distinctive shape and also happens to contain the brightest star in the sky, which is Sirius. So Sirius is around between 7 and 8 light years away, quite luminous, and it's actually a very interesting double star. It's interesting because it's quite a challenge to observe, and also because its companion is in fact not a star that's still undergoing fusion and generating energy. It's in fact a white dwarf, so the core of a star that has gone through its whole evolutionary stage. So you might recall last month we took a look at Rigel, and Rigel was also a double star, and the separation of Rigel is very similar to Sirius. So if you take a look at Rigel, that will give you an idea of how close the companion to Sirius will be. But Sirius is a much more challenging observation simply because the difference in brightness between Sirius and its companion is much greater. So in general with double stars, particularly close double stars, the greater the difference between the brightness, the harder it will be to split those two components. So it's a good idea, take a look at Rigel just to get an appreciation of the distance involved, and then you can swing your telescope over to Sirius. So when making these sort of observations, it's often very helpful to know whereabouts in the field of view to look. So that's actually quite easy to determine in this case, because Sirius B, or sometimes called the pup, always follows Sirius. So in other words, it's like a puppy and it's following its parent. So the best thing to do is, if you have some sort of drive on your telescope that tracks the sky, switch it off. And of course, if you've got a manual scope, just simply stop moving it. Put Sirius into the center of your field of view, and then it'll start to drift across the field of view. And that direction will be west. So I've marked that with this dashed red arrow here. And Sirius B, the companion, will always be behind Sirius. And at one stage, it was pretty much right dead behind it at 180 degrees. But at this time, in 2023, because of course they're in orbit, the two stars are in orbit around a common center of gravity, so their relative position changes with time from our point of view. So at the moment, it actually forms about 120 degrees. So Sirius is drifting this way towards the left. So you'll find Sirius B not directly behind, but at an angle like that. Now, this diagram shows you the view through a reflector or a Newtonian telescope, which really doesn't do anything funny. It doesn't do any flipping around or anything like that. If you're looking at it through, let's say, a refractor or a Schmidt-Cassegrain and a star diagonal, it will still drift. The drift direction will still be west, and it will still be behind, but it may in fact be up in this direction here, like that. So when you do eventually spot it, well, I should say firstly, you need to use plenty of magnification. So I can usually see it quite well in my 12-inch telescope. I use about 200 to 250 times magnification. I can also often see it through an 8-inch telescope, and I use between 150 and 180 times. So you need to use as much magnification as you think you can get away with on the night. And the other thing is, you do need a night of good seeing. So when you look at Sirius, you want it to be one of those nights where it looks like pretty much a nice, sharp, intense white and just a little bit of fuzziness around it. If it's one of those nights where it looks like just a giant fuzzball wavering around, then unfortunately you won't be able to see Sirius B, because it'll be lost in that fuzziness. So you have to be persistent and keep checking until you get a good night. But it's worth the wait when you do finally see it. And when you do finally see that little tiny companion next to it, it's worth bearing in mind what you're actually looking at. So what you're looking at is a star that is no longer shining. It's gone through its supergiant phase. It's puffed off its outer layers during a brief period of being a planetary nebula. And what you're looking at now is the remaining crushed core of that star. So that star is no longer generating energy via fusion. What's left behind is that core consisting of degenerate matter. So degenerate matter, in this case, basically means it's been crushed during the later parts of the star's evolution, so much that all of the electron orbital positions have been filled, and it just can't be crushed any further, unless it's a big star, in which case it'll go into a neutron star. So that matter is extremely dense. You've basically got the mass of our sun compressed into an object that is around the size of the Earth. So the radius of that white dwarf is very similar to the Earth. So its density would work out to be around 1 megaton per cubic meter. Done my maths correctly. 1 megaton per cubic meter, that would work out at 1 ton per cubic centimeter. So that means if you could imagine holding a little cube 1 centimeter by 1 centimeter, that little cube would weigh 1 ton or 1,000 kilograms. Quite amazing. So the next object, I've just turned on the deep sky objects, and you can see there's an enormous amount of objects in this region of the sky. We're looking at a lot of local Milky Way objects here. So the next one I wanted to take a look at was M41. So M41 is actually there. So very, very easy to find. You'll certainly be able to easily sweep it up with binoculars. So the best thing to do is really just imagine the line between Sirius and this star here, and it kind of forms sort of a very fat isosceles triangle there at the tip there. So that's where you'll find the open cluster M41. So reasonably close cluster at around 2,000 light years away, and its age is around 190 million years. So sometimes called the Little Beehive cluster. So what you'll see is quite a few bright stars, not as many as you see in this photo taken with a large telescope. Most of the stars will be a nice bright white. But towards the center of the cluster, you'll certainly be able to see at least two quite distinctive red stars as well. So now moving along again, we're going to look at another very nice cluster called the Tau Canis Major cluster. And that is found right over here. So its NGC designation is NGC 2362. And it's centered around this star here, Tau Canis Major. So Tau Canis Major is magnitude 4.1. So it's a relatively bright star. And you can kind of follow a line down from this star here to find it. And this shows you, if you've got a TELRAD, where to place it. And you can also usually sweep it up with your binoculars as well. So this is a really, really nice cluster, very different from M41. So M41 is quite a large cluster. You need, makes a reasonable binocular object or a wide field eyepiece in your telescope. Tau Canis Major, on the other hand, is very compact. So what it will look like, you'll see a really bright star, which will be Tau Canis Major, and it will be kind of sort of surrounded like a donut almost of all these stars. So if you take a look at it under suburban skies, these stars tend to be hard to actually resolve. So it'll kind of just look like a faint, beautiful blue sort of foggy ring surrounding Tau Canis Major. Under darker skies and of course more magnification, you can then start to resolve many of these stars. So as opposed to M41, this cluster is very, very young, only around 5 million years old. So what you're looking at here is all of the new stars that have been formed in this cluster, and they're very, very hot, young. Most of them are type O or type B stars, so very, very hot and luminous. And in fact, it's understood that Tau is also a member of that cluster as well. It's not just a foreground object. So our final object of interest is actually we're going to sneak over the border into Puppis. So you can see Puppis is quite a large constellation, and it kind of officially sweeps under Canis Major. And where we're heading is towards M46. So M46 is right here. So sort of a little bit in sort of no man's land in a way, but I guess one easy way to find it is you've got Sirius here, and you can kind of form a line between these two stars. And if you keep going in that same direction, about the same distance, it'll take you around into that ballpark where M46 is located, near these bright stars. So this is really one of my favorite objects. It's a really special object. The reason being, it's not only a very, very nice open cluster, but it also contains a planetary nebula. So when you observe this object, you won't have any trouble seeing the cluster itself. It'll look like this beautiful open cluster. It consists of numerous stars. But then if you look very carefully towards the edge of the cluster, it usually appears that you'll just see this sort of little round greenish disk, and that will be the planetary nebula. So sometimes it pays to use a little bit more magnification, try and zoom in on the cluster to spot the planetary. And again, of course, particularly under a suburban sky, if you can flip, say, an oxygen 3 filter in and out, you'll readily see it because the planetary nebula will show up in that filter, whereas the stars, of course, will dim out. So a really nice object and quite unique as well. Just one interesting note that the planetary nebula itself is not a true part of the cluster, even though it appears to be from our perspective. But you can see the distances here. The distance to that cluster is around 4,900 light years away, whereas a planetary nebula is around 1,300 light years. So that planetary nebula is actually a foreground object from our point of view. Thanks, everyone. I really appreciate you joining me for this month's show. Hopefully you'll get some good weather and some clear skies so you can get out and observe some of those wonderful objects. And I look forward to seeing you for the March show. Bye for now.